You are struggling with the data analysis assignments. Many of you have handed them in, and they've not been very good, to be frank. Some of you have done a really nice job, and they're fine. But I felt that I needed to give you a little more guidance and maybe go through an example of what I was looking for in those assignments. So I wanted to start with a little review of your book. This figure is in your book. It helps us decide what type of analysis we're going to do and where we're going to go and what we're going to conclude and so on. So this is the roadmap in which we need to use. So we need to ask these questions like, is our particular design, is a particular scenario that we've been given, is the independent variable between subjects or within subjects? And if it's between, is it a manipulated or subject variable? And if it's manipulated, did we do random assignment or did we do matching? Is it, if it's a subject variable, what is it? If it's a within subjects design, how often was it manipulated and by who and so on? And then we wind up with these 4 particular kinds of designs, and this will inform our analyses. So in a lecture that I did, I want to translate this stuff that was from a previous lecture that I did, and the video is on YouTube, and there's links on Canvas, and I think the lecture itself is also posted on Canvas. I want to translate this into this. So we have independent groups, matched groups, one-factor design, ex post facto one-factor design, and repeated measures one-factor design. And I want to come to some agreement about what each of these 4 refers to in these 4. How do these match? So between groups designs can be arranged in 3 separate ways. We can have 2 separate groups with a manipulated IV. You can have 2 separate groups with a subject IV, or you can have 2 matched groups with a manipulated IV. So I went through some examples of these. And then within subjects design is when you have just one group of subjects, and you manipulate the IV. So what makes it a within subjects is that every subject gets every treatment level. So in a single factor 2-level design, so that means that there's one independent variable. Single factors and independent variables are the same, they're synonymous. So single factor, one IV with 2 levels. That means 2 groups or conditions or amounts of the independent variable. That gives us 2 groups or treatments or conditions. Okay, so placebo versus control, if these groups are not intrinsically related, then that's a between subjects group design. If we're not manipulating the IV, but we're using some property of the subject, like whether they're intrinsically high anxiety or intrinsically low anxiety, if we're dividing the groups by some subject variable, we could do male versus female. That would be another subject variable, ethnicity, various things. When we match the groups and manipulate the IV, that means if we get subjects in and we say, okay, well, we're going to put pairs together based on their IQ, based on their gender, based on their race, based on their whatever, and put one in one group and one in another, that is a matched group design. And within subjects are repeated measures. So this is the independent groups one-factor design. This is the ex post facto design. This is the matched group design right here. And this is the within subjects repeated measures design. So these names here correspond to these names here, which I would call these things. Now, these 2 types of designs in green represent independent samples, but these 2 in blue represent dependent samples. So the way I organize this is a little bit different than the textbook organizes it, because I like to think of these as independent sample designs and dependent sample designs, because what we do to these in terms of an analysis is the same as we do it is the same, whereas here it is the same. So when we have independent samples with 2 levels in a single factor, we can do a t-test for independent samples. Now, the other thing that we can do is that we can do a rank sum t, and I went through the logic of why we might choose one over the other. And this is a non-parametric. The rank sum t is a non-parametric. The t-test is a parametric. So there are more assumptions when you do a t-test than when you do a rank sum t. Likewise, When we have dependent samples, we're going to do a t-test for dependent samples, or repeated measures, or matched pairs, or correlated samples. They're called a lot of different things. We're going to do Wilcox, or we can do a Wilcoxon signed ranks test, which is the non-parametric alternative for a dependent sample single factor two-level design. Now, I went through why you might use one over the other. You don't choose a t-test for independent samples versus a t-test for dependent samples. You never do that. You would choose either a t-test or a rank sum t. You would choose to do a t-test or a Wilcoxon signed ranks. You don't choose in between the four. You either choose this one or this one, or this one or this one. Now, you've already decided whether you have independent samples or dependent samples. That's not a choice. Your choice is you can do this test or this test for independent samples. But if you have dependent samples, you can do this test or that test. This is based on how you feel about your assumptions. Assumptions of normality, homogeneity of variance, interval, ordinal level data. Those are the assumptions that you need to consider. I talked about that in the previous lecture. Now, if we are generalizing to 3 levels, so we have a single factor 3-level design, right? It means we have 3 groups, treatments, or conditions. Now, the same things hold. We can do 3 separate groups in like placebo versus drug versus control. We can have 3 separate groups with a subject IV. We can have 3 matched groups with a manipulated IV. We can have 1 group where we manipulate the IV and has 3 levels. This I have a little typo here. I didn't include a 3rd group, but there should be a 3rd group in there, okay? So once again, we have an independent groups 1-factor design. This is an ex post facto 1-factor design. This is a matched groups 1-factor design, and this is a repeated measures. Again, these are independent samples. These are dependent samples. So when we go to do a statistical test on a 3-level single-factor design, we can do, if we have independent samples, we can do an ANOVA or a Kruskal-Wallis. If we have 3 levels in dependent samples, we can do an ANOVA for repeated measures or a Friedman. So that parallels the t-test. In fact, the ANOVA and a t-test are a related family of statistical tests, all based on the same logic, okay? Now, dependent samples and independent samples, we can have 3 levels. You can have 4 levels. You have 5 levels. You can have 77 levels. You're going to do the same analysis. So the exception, the only difference here is whether you have 2 levels or more than 2 levels. But I didn't want to confuse things, but I guess I am now. Okay. So I'm going to leave off here, and then I'm going to come back and talk about an example of a